Hey guys, today I'll be teaching you L'Hopital's rule. So solve this limit. Limit of sine x. Oh, this is way too thick. Okay, let's try that again. Okay, so as I was saying, limit of sine x over x as x approaches 0. As x approaches. So pause this video and try solving this on your own. So if you substitute 0 for x and solve this limit normally, you'll get 0 over 0. That means this is in indeterminate form. Indeterminate form is 0 over 0 or infinity over infinity. If a limit's solution is in indeterminate form, then you have to apply L'Hopital's rule. So L'Hopital's rule states that if a limit results in 0 over 0 or infinity over infinity, we can take the derivative of the numerator and denominator separately and evaluate the limit again. After evaluating it again, if you still get your solution in indeterminate form, then you have to apply the rule all over again. So now let's go back to the initial example. So let me rewrite it. So if we go back to our original example, we got, so this time we'll take the derivative of sine x and x. So the derivative of sine x is cosine x, and the derivative of x is simply 1. So if you simplify this, you get cosine x. Now if you substitute 0 in for x, you'll get 1. So cosine of 0 is 1. So the solution to this limit is 1. Let's try another example. Okay, so you have limit as x approaches infinity of x over e to the power of x. So if you substitute infinity for the numerator and denominator, you'll get infinity over infinity. This means this is in indeterminate form. So now we have to apply L'Hopital's rule. So the derivative of x is 1, and the derivative of e to the power of x is e to the power of x. So now if you substitute infinity, you'll get 0. So 0 is a solution to this limit. Okay, let's try a few more examples. So we have limit as x approaches infinity. So limit x approaches infinity of x squared over e to the power of x. So if you simplify, if you so now if you substitute infinity in for x, you'll get infinity over infinity, so it's in indeterminate form. Now we apply L'Hopital's rule. The derivative of x squared is 2x. The derivative of e to the power of x is e to the power of x. Now, if you substitute infinity again, you still get infinity over infinity. So this is one of the cases in which you have to apply L'Hopital's rule multiple times. So if we apply L'Hopital's rule again, you should get 2 to the power of 2 over e to the power of x. So now if you substitute infinity, your final answer will be 0. So the solution to this limit is also 0. Okay, let's try one more example. So try this. Limit as x approaches 0 of sine of 5x over x. Okay, so try this one on your own. So you should get so when you substitute 0 in, you should get so if I substitute 0 in, I get 0 over 0. So that means this is an indeterminate form. So now I know this is an indeterminate form, I can apply L'Hopital's rule. So if I apply L'Hopital's rule, the derivative of sine of 5x is cosine of 5x. Over 1. Sorry, not over 1, over 0. Wait, no, sorry, it is over 1. What am I saying? Okay, so now you have to go and simplify. But wait, there's a mistake. Yes, this 5, when I was taking the derivative of sine of 5x, the correct answer is 5 cosine 5x. So now if you simplify, you should get 5. So the solution to this limit is 5. Okay, that's the end of this video. Thanks for watching. Bye.